Hi, welcome to our math. Today I'm doing a series of videos on higher order polynomials and finding their solutions. In this video, I'm specifically looking for real solutions, so we're not going into the imaginary plane, though I am going to note it on one of these two problems. Now, both of these are quadratic-like, and what I mean by quadratic-like is anything that's in the form of ax to the 2n plus bx to the n plus c. So our exponents go double, single, zero, can be factored in the same way that you do any other quadratic. Now, if you are comfortable with factoring quadratics, you could do it brute force. You could just do the pattern, go about it. The beginning of your parentheses, start with whatever your middle variable is. And when we work through this, you can kind of see how that pattern works. And if you are truly comfortable with it, go for it. What I'm going to do is something a little bit different. I'm going to make it conceptually simpler. I'm going to use a little bit of substitution, and it's just going to make it visually easier to do. It's not going to inherently change the problem at all. It's just going to make it visually and mentally easier. What I'm going to do is I'm going to say, hey, this middle term is our key. It's always the middle term that's the key. I'm going to say, I want u to be x squared. Then u squared is going to be x to the fourth, because if I square u, I have to square x squared. So now, if u squared is x to the fourth, I can change x to the fourth to u squared. If u is x squared, I can say u squared plus 13u minus 48 equals 0. And what I just did is I just made this exact same problem, same numbers, same everything. It just looks better. It just, in our head, it's exactly what we're used to seeing. Okay, so then what I'm going to do, now that I have this with a equals 1, I need two numbers that multiply to 48 and add up to 13. Very similar to what we're used to doing. 48 is negative, which means one of my factors has to be negative, and because 13 is positive, it's going to be the smaller factor. That is not 13. Negative 2 and 24 is not 13. Negative 3 and 16 is. So I'm going to have, we always use our middle one, u minus 3, u plus 16 equals 0. I'm now going to come back to my original variables. I'm going to take the u and replace it back as x squared minus 3, x squared plus 16, and we're right back where we started. So I just used those u's for just a small few seconds to help along the way. All right, so then two items multiplying to be 0, one of them has to be 0. Either x squared minus 3 equals 0 when x squared equals 3. I'm going to do a square root. I have to acknowledge it could come from a positive or negative place. So x is negative the square root of 3 or positive the square root of 3. Do the same thing. X squared equals negative 16. And here we have a problem. We can't do the square root of a negative number unless we're going into the imaginary plane. So because it says real solutions only, this is not possible. If you are doing imaginary numbers, this would be plus or minus 4i. But because we're asking for real solutions only, we're actually stuck with only two solutions. Okay, so let's see how this looks again with a different problem. Again, the key is the middle term. We're going to let u equal the square root of x. If we square both of these, u squared equals x. So u squared plus 10u minus 39 equals 0. And once again, we are in a position of a type of problem we're more comfortable with. And that's all we're doing with this substitution. Again, 1 and 39. 39 is negative, so the signs have to be different. 10 is positive, so negative 1 and 39. -3 and 13. There we go. U minus 3, U plus 13. And now we will come back and say the square root of x minus 3, the square root of x plus 13. Square root of x minus 3 equals 0 when the square root of x equals 3. Square both of these, and x is equal to 9. Square root of x plus 13 equals 0 when the square root of x equals... This is never going to work because the domain of the square root of x is 0 to infinity, all positive numbers. That's never possible. So this is always going to be a big old no. So our only answer is going to be 9. Whenever I'm dealing with square roots, like always, I'm always going to check my solution because square roots have a way of slipping into weird answers. So if we just check, is 9 plus 10 times the square root of 9 minus 39 equal to 0? It's not a bad idea to check it for all of them, but with square roots, I'm always doubly cautious. 9 plus 10 times 3 minus 39. This is 9 plus 30, that's 39 minus 39. That works. So I just, with square roots, it's just always doubly, quadruply good to check your answers. All right, I hope you enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video. Thanks.